let's get started. Is this on? Yes, this is on. So welcome to the last class of 340. There are no more assignments, so congrats on being done with all of those. I know they've been a lot of work. You probably all know there's a final exam coming up on the 14th, which is a week from tomorrow. And as I mentioned last class, it'll cover assignments 1 through 6 and lectures 2 through 31, meaning up to last week, but not including this week. And there are past exams posted online, and there's same rules as the midterm. We scheduled a bunch of office hours for next week. There's 14 office hours at the moment, or 14 hours of office hours. So check the calendar as well for that while you're preparing for the exam. So today I want to do some wrap-up stuff. Oh, good.
So you said that the midterm was too high of an average, blah, 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 so you want to make it harder. What sort of things would you make harder?
What sort of things would I make harder on the final? Why don't you ask that on Piazza? It's
lengthy question.
one of those questions that's easy to mess up. Yeah. Okay. So from my perspective, one of the big ideas of the course is, anyway, you're a grad student, Fed, it doesn't matter. One of the big questions is supervised versus unsupervised learning. And we talked about both in the class. And supervised learning is this idea of I have input-output pairs. Let me learn that relationship so I can predict outputs. Unsupervised is slightly more vaguely defined, finding patterns. Maybe the most important idea, oh, what? No one? You guys. So quiet. One of the most important ideas in the course is this fundamental trade-off, this overfitting versus underfitting. Do I make my model really complex, but then I can overfit so I can make the model simpler, or I can also use regularization, all that kind of stuff, validation sets, all these kinds of things. This golden rule of machine learning, as we call it, that the test data shouldn't influence the training data. We talked about optimization bias and maybe having an extra validation set to check for this like we had on the assignment. We talked about the idea that there's no best machine learning model that's going to work best in all circumstances, and that's why we talk about a bunch of different things in the course. And I kept talking about these 3 steps, and I added a 4th step today. Well, I added it to the beginning of the list, which we didn't really talk about much, but this issue of getting the data, pre-processing the data, or even deciding what features you want to collect or how to collect them, all these kinds of things. But we talked a lot about those other 3 steps, which is I pick my model, which determines what sort of relationships I can learn, and then my loss, which determines which one of them do I consider the best or better than others. And then I got to actually solve the numerical computational problem of minimizing that loss, which gives me the best model. So that's the paradigm we've been exploring. There's other ways of doing machine learning, for example, the Bayesian paradigm, which we didn't really get into much in this course. In terms of individual topics, I'm not going to read all the things on this slide for you, but I highlighted in blue the things that were covered on assignments because I'm more likely to put those things on the exam since you've spent more time dealing with them on assignments, so you can refer to this later. But we roughly had these 5 parts of the course alternating between supervised and unsupervised. So there's also a bunch we didn't cover. Of course, what we didn't cover is actually a lot more than what we did cover, but we still did quite a lot. So we didn't really say anything about data collection, very little about pre-processing, causality. So for example, we talked about feature selections, and these features seem important, but is that the cause of the output, or is it correlated, that kind of stuff we didn't really get into. Time series data is something I kind of want to add to the course because it seems to be maybe the #1 thing that people ask me about that we don't cover in the course. There was a little Piazza discussion, but we mostly didn't talk about the broader impact of machine learning on society. We mostly didn't talk about bigger problems where you can't fit your data into memory or your model, and you need to scale it up to a whole bunch of nodes. We briefly talked about the cloud, but not about, I want to do this over a whole bunch of nodes. They're all doing gradient descent, and somehow I'm distributing the computation. That adds a whole level of complexity to what we're doing. Another thing that I think is really important that we don't cover really at all in this course is how do you communicate the results. So the assignments in this course usually end with report your validation error, and you write like 0.07, and then you move on to the next question. But that's not where it stops, right? Because usually you're doing this for a reason, and usually there are other people involved. And 0.07 doesn't mean anything by itself. Is that good? Is that bad? What decisions might you make based on that result? Can you communicate this with a visualization, with some other sort of packaged pipeline that people can use? So I think that's a really important piece that we didn't really cover to my satisfaction, and that I'd like to move towards in the future, but there's only so much we can really do in one course. Any questions or comments about this? Okay, so I do want to say we still did a lot of stuff, and you should feel the sense of accomplishment with my initial reaction to, hey, Mike, can you teach this course, was, whoa, that's a lot of stuff to put in one course. So good job on sticking with it and covering really a lot of material, in my opinion. Some people have asked me about Computer Science 540, which is sort of the natural next course if you thought this was interesting. So in this course, we talked mostly about implementing practical machine learning algorithms. And in 540, on the other hand, it's research level machine learning. So the goal would be at the end of 540 to understand research papers in the field and a whole bunch of more sophisticated stuff that we didn't cover in 340. As I think I've mentioned to you a few times, I think there should be and will be a third thing before 340 that covers more of this, the whole pipeline of preprocessing and communicating and interpreting without necessarily needing to implement everything. So that's in the works, but probably, well, definitely too late for all of you. Sorry. So in terms of 540, questions like how many iterations of gradient descent do we need to do? We never really talked about this. We just said, well, like, I'll do 100 and call it a day, or I'll do it until the magnitude of the gradient is small and call it a day. But we didn't really analyze how many we might need. And sequence data, so a whole bunch of data comes in the form of sequences, including text and all that kind of stuff, is covered in 540. So I think there's a bit of a misconception that that course is only open to graduate students, but that's not true. You need more preparation to get into the course, but it is open to undergrads. Here's a list of a whole bunch of other courses that are relevant. I think they're all grad courses, mostly all, not all. I don't want to actually go through this, but I just want to flash it up on the screen, and you can refer to it if you're interested in continuing with ML. Okay, the last couple of things I wanted to do before we conclude the course is talk a little bit about grad school, because it's a very common question that I get. So I just have a few thoughts that I thought I might as well share with you all. So my main piece of advice is don't do it. Yeah, for some of you it's too late, I know. But for the rest of you, there's still hope. And if you insist on doing so, then I have some things to say. So One thing I suggest is get as much work experience as possible. I really like the UBC co-op program. It's great that people graduate with 20, 24 months of work experience. That's really great. There's also, I would encourage you to consider working after undergrad for a couple of years if you're not sure about grad school. If you're accepted to grad school, I also encourage you to ask if they accept deferrals. Often you can ask, can I start a year later? Often they'll say yes, and then you could work for a year, or do whatever you want. But that's a really nice thing to explore as well, because you can just relax. You have your spot all ready to go. And even once you're in grad school, it's super common to do internships. It might seem like you're behind on your research. There's only one state of grad school: being behind on your research. Trust me. So it's okay. That's just the way it is. And I think it's worth it to go do internships. And the reason why I think this stuff is so important is that you see how things are done, you build skills, working with teams. Grad school is often a bit more of a solitary experience. I mean, there's collaborations, but not to the extent, I would say, of being out in the workforce. And another thing is just, you don't want to go to grad school because going to work is kind of this intimidating thing. And for most of you doing co-op, that's already off the table. But you want to kind of know what your options are and then make a conscious decision to go to grad school. And that's also why I put boredom on there. So boredom is this very valuable asset that you may be able to find yourself in possession of sometimes. And it's a great motivator to go do the next thing. So I'm not saying most jobs are boring or anything like that, but if you find yourself bored doing what you're doing, it's been a few years, or curious about how could things be done better, I think that's a great way to say, oh, maybe I should apply for grad school, rather than, well, I just finished undergrad, I'll just go to grad school because I've been in school since I was 5, so I'll just continue being in school because that's what I do, right? That's what I want to recommend you avoid, because I think you're more likely to be successful in grad school if you go as a conscious decision rather than as a going with the flow type thing. As you may or may not know, there's sort of 2 main categories of master's degrees that you could look into. One is the standard research master's, which is about doing research, which basically means reading and writing papers, trying to come up with new stuff. And that leads to a PhD, academia, all that kind of thing. And there's also professional master's programs that are usually course-based rather than thesis-based, and they're trying to get you ahead in what you're doing. So as you might know, I'm very involved with a professional master's program at UBC, which is the Master of Data Science program, which I wouldn't recommend to any of you because you've already taken 340, and that's not really the target audience. It's more for people transitioning from another career path. But in any case, yeah, so professional master's programs can often be very expensive. Research master's programs pay you, right? It's not like amazing big amounts, but there's a financial difference in that sense as well. You know, it's a complicated analysis because you may do a quick professional master's, get back into the workforce faster, and it could pay for itself quite easily. It sort of depends on the details. Another thing I want to say is, if you're interested in machine learning specifically, just keep in mind Canada is really strong in machine learning, so it's not like you need to look really far to find a world-class machine learning group. I also have some comments and advice on getting yourself ready to be an attractive applicant for grad school. And a really big thing that I recommend is do interesting side projects. And actually, this isn't just for grad school. This is also, or maybe even more so, for going into the workforce. And you probably already know this by now, but your GitHub is kind of becoming like the new resume in a sense. And if people can go and see what you've done, that's more information than you just putting a line in your resume about what you've done. And it's not that they're going to spend hours looking through all your commits or anything like that, but it shows interest in building things, and it shows the type of code you can write and the type of documentation you can write. If I'm checking someone out and going to their GitHub, even if the code is beautiful, if I go there and the README is like one line, I'm actually not that impressed no matter how good the code is, right? Because I want to see like this is what it does, this is how to set it up, and showing that you have those kinds of skills is really valuable. Also really recommend, if you have time, making yourself a website and or blog. So for students in our Master of Data Science program, this has proved to be very effective, and students have gotten contacted by companies saying, hey, I saw your blog post on doing something or other with news articles. That's what we do. Can we interview you or something like that? Because again, it shows that you can take initiative and write well and present your analysis and do the analysis, and it can really be a boost to your career. It doesn't have to be, you don't have to have a blog with a huge readership, but for someone to stumble across it or to look you up and then come across it is really nice. For the Research Master specifically, probably the single biggest thing that could help your application is having prior ML research experience, or replace ML with whatever field you want to go into. I'm not saying this is a necessary condition for being accepted. It isn't. But if you're hiring someone to do something, the best thing ever is if they've already done that thing, right? And that thing in grad school is research. So if you can say, I've already done exactly what you're hiring me to do, check it out, then that's a really big boost to your application. So then I have some specific suggestions for preparing the application itself. One is about picking referees who are going to write you reference letters. So I think it's pretty common that people try to get reference letters from the biggest name in the field, or someone who seems relevant in some way, or whatever it is. But really, I think the most important thing is how well does that person know you? Because if you get the biggest name in the field to write you a reference letter, what are they going to write? Like, hi, I'm so-and-so, but I can't say anything about the applicant. All it really shows is you convince that person to write you a letter. But if they can't say anything, it's not actually that influential. But if you can get someone to say, I've worked with this person for 2 years. They are in the top 5% of students or employees that I've interacted with. They were on time and organized and took initiative, and like they seem to me like an ethical, upstanding person. Like, wow, right? That is way better than empty letter from famous person. And same thing with course instructors. If you have a course instructor, if they don't actually know you and you just took a course for them, I know what these letters look like because I write them all the time. They just say, like, so-and-so was in my class. Their grade was whatever. That puts them at their rank in the class at whatever. Unfortunately, I'm unable to comment about their research ability, communication, et cetera, because I don't actually know them. And it's okay, but, I mean, it's not going to tank your application, but it doesn't actually really add anything that wasn't on your transcript, except, okay, maybe the class rank, but you can kind of tell if the grade is good or not just by looking at the grade, and it really doesn't end up adding anything. So I would say you may be forced to get that kind of letter because they require 3 letters and there's only 1 or 2 people who are appropriate and know you really well. And then, sure, you just have to fill it in with this because that's the required number of letters. But I wouldn't go there first. I would go there as sort of a last resort. And I mean, personally, I'm very upfront about this when people ask me, can I have a letter? I say, sure, just so you know, this is what it's going to be. And they say, that's fine, I understand. And then I do it, and then often they get admitted to the thing. And it's not because of my letter, right? But it's just they needed one, and I'm totally fine with that. But I just want you to be thinking strategically about this kind of thing. The other point here is try to gauge if the person's enthusiastic. If they're like, yeah, of course, I'd be happy to, great, right? Then they're probably going to put effort into this. But if they're like, well, I'm kind of busy, are you sure? Like, you may want to read into that because their enthusiasm about writing it is going to show through in the letter itself. Okay. Furthermore, a really common thing that I see when I'm reading applications is people have really low grades. It's very common, especially in, say, first and second year, and then they improve. But it's night and day for me if those grades are explained versus not explained. So it's never better to just hope they're not going to notice, because they're probably going to notice if it's like, F, D, C, like they're looking at it, right? So, I mean, it's hard to hide those things. But it's not a deal breaker. It doesn't mean you can't get into the program, because maybe you have something to say. Like, when I started my degree, I wasn't that engaged because I didn't really know what I wanted to do. I didn't take it seriously. I failed a bunch of courses. Then I found my interest in X. I took those courses. Like, everything went great. As you can see, my third and fourth year grades are like A range. And then I'm like, okay, sure, that makes sense, right? So, of course, you should be honest and not make up some explanation that isn't true. But often there is something to say. And it's really, really important to just get that discussed head on rather than just kind of hoping for the best. I think that's quite critical. So then in terms of you're already at UBC, this sounds kind of interesting despite Mike's warnings. There are those courses that I mentioned earlier, and then I think the most useful things to do are just do projects. And again, it could be with a faculty member or with a company or whatever, but it doesn't have to, right? If you find something that's of interest to you, like, hey, there's this paper, I'm going to implement the thing in this paper in Python and put it on GitHub and write a nice, like, README or whatever. That's a valuable thing. You're going to learn a lot, and people are going to be impressed. So my kind of sub-advice for that is pick something that's fun, because the quality of the project is going to be how much time did you put into it, and how much time did you put into it is going to be how much fun you're having doing it. And since it can be anything anyway, just pick something you're interested in. If it's music, do like a music computer science thing. If it's hockey, do a hockey prediction of playoffs, or whatever it is. You might as well just enjoy it, because it'll actually benefit you if you do it that way. Any thoughts on this? Yeah, Jeannie.
I mean, it's just funny that you put "don't do it" as your first tip. So I'm kind of curious, what was the reason you go to grad school then to begin with?
Why did I go to grad school? So most of the advice I give is based on things that I did and then I didn't think it worked out, or didn't think it was a good idea in hindsight. So my personal situation was I was in this very research-focused undergrad program. I did a ton of research in undergrad. I was just like, everyone was expecting me to go to grad school. All the professors were expecting me to. Like, a lot of my friends were doing it. And I was just like, well, this is what people do. I mean, it's just like the next thing, right? So I just kind of ended up doing that. But I never really, stopped. What am I doing with my life? Like, why am I doing this? It wasn't like an active decision, and that's what I was trying to get at. It was more of a passive decision. I think if it's an active decision, not only does that mean you'll have actually thought about it, which is important, but also you'll be more motivated, because it'll be this thing that I've thought about. Oh, I'm actually getting really excited about this. I should go for it. I'm going to do it. And then you're there. And I think it's also better when you're there. So it was kind of a joke, but kind of not a joke when I said don't do it. It's just not something everyone has to do. And sometimes you get this weird impression that it is, because you've been in undergrad for 4 years, and a lot of the people you interact with, like me and all your other instructors, have PhDs. So you're like, oh, people have PhDs. That kind of makes sense. But that's not what the world is, right? And that's one reason why I like the co-op program so much, is because you all get out there and see other stuff, which is often really great, and then you decide to go and pursue that other stuff. Okay, the last thing I have for you is some general life advice, which, unlike the grad school advice, no one asked me about this, but I decided I'll say it anyway. So let's see if we can do this in 8 minutes. The first thing is to try and find an intersection of work that is kind of a good field to be in and something you enjoy. And this bullet point doesn't apply that much to this group because if you're in computer science, that's already a field where there are jobs, and you're lucky that you probably don't have to make that trade-off that many people make between their passion and the thing that brings home the paycheck at the end of the day, right? Presumably, if you're here, you're lucky enough to be in that situation where those things are aligned, but it's an important alignment that everyone needs to make. I would, I guess, just say, in terms of deciding what you enjoy, don't forget about that part. That's a really important part, and you can't really be good at something unless you enjoy it anyway. So you should really take that seriously. And you should decide where there are careers. I mean, it's interesting. For example, kids in high school that I talk to have never heard of computer science, or I went to talk to some first-year science students, and I was like, I'm going to tell you guys about computer science. And they're like, why? Can you get a job in that? And I was like, are you kidding? So you should do your research and understand the landscape, because it might not, sometimes no one tells you and then you don't know. So you should figure that out. It's kind of on you to know these things. So another thing I want to talk about is grades. People often obsess over grades, and by people, I'm definitely including my past self, and that's why I have this on the slide, and I think that's pretty dangerous. So grades are a means to an end. They are not an end. You should know what the grades are going to do for you. Is this grade going to get me a scholarship that I need to pay my tuition? Is this grade going to get me into grad school? Because if you don't know what it's for, just forget about it. I mean, this is your life. You have better things to do than try to get 97% instead of 90% on whatever exam. Like, who cares, right? Unless it's for a specific purpose. So I urge you to kind of think about it, and you don't just need to maximize that function like as much as it can possibly be maximized, right? Your function needs to involve all the other terms, which are like your whole life, and then decide what is the best thing for me to do. And often people get really worked up about grades, and I think that's kind of a danger. And also people, like, we all have this number attached to us, like our GPA or our grade in the course, and sometimes it's almost like people are walking around campus like, oh, I got A+. Look at all these people, right? Like, you should not do that. I mean, it does not make you like a superior person just because you got a bunch of A+. And the other hand is true too. It does not make you like a worse person, and you shouldn't walk around campus if you have a C+ average and be like, oh, these people are better than me, because they're not better than you, right? They just focused on different things for whatever reason, and it kind of depends. And I think it's a bit of an unhealthy, again, I feel comfortable saying this because I was definitely one of those people, but it's a bit of an unhealthy obsession. I guess just keep in mind, as I was saying, in the parlance of this course, like there's a lot more to your loss function than just negative GPA, right? That's good to keep in mind. Ian.
I just want to add to that. They did a study a couple years ago, and they found that the average GPA of millionaires in the US is 2.9. Okay,
Ian says they did a study, and they found the average GPA of millionaires is 2.9. So, I mean, sure, yeah. I mean, being a millionaire is also not necessarily everyone's goal, but yeah, grades measure a very particular thing very imperfectly, and yeah, I mean, they might. So, for example, they don't necessarily correlate with success in research or that kind of thing. Another thing I see people happening is that they're not enjoying themselves because they're working towards the next thing. Like, oh, I got to get into this university. Okay, I'm at UBC. I got to get into this grad school. I got to get this scholarship. I'll be happy once I get in. But like, that's never true. Like, once you're in, there's always the next thing, right? So if your mindset in life is, I'll just delay being happy until I get the next thing, you're never going to be happy. And you'll just always be in that state. So don't forget to keep the present in mind and try to actually enjoy what you're doing, because there's no going back in time, right? Like all that time you spent being miserable is just time where you were miserable, and there's nothing you can do about that after the fact. So I really urge you to not get into that loop of always going after the next thing. I also want to say, yeah, don't assume the system makes sense, where the system could be a whole bunch of different things, but for example, like your educational system. So we try to make our courses relevant, like we really do, but it's hard because things are always changing and we're busy, and there's all kinds of stuff that can get in the way of whatever you're doing from being the perfect, say, education system. So it's really on you to think it over and decide, like, you know what, I'm not learning the skills I need to learn in this course, so I'm going to go figure this thing out on my own, or whatever it may be. You know, maybe things are out of date, all that kind of stuff. I mentioned this graduate research thing. You often get these straight A students coming to PhDs. They're like, but I'm so good at writing exams really fast and not making any mistakes. Why am I not the best at inventing new things for 5 years straight? Right? But like, why would you be, honestly, right? So, yeah, be careful about that, and don't hesitate to question the framework that you're put in, because probably people have put a lot of thought into it, but also probably it's still imperfect. Last thing I want to say is just don't forget that even just by being in this room, you're all very lucky. So we're here, we're not in the middle of a civil war or anything like that. And I'm not joking when I say this, right? We're in like a reasonable place. We're in an amazing university in this reasonable place. And we should just keep that in mind and not forget about that too often. And just kind of appreciate what we have here at UBC. And even though I said that, still don't hesitate to challenge the system, because there's always things that can be done better. So that's all I've got. Thank you for taking this course. I hope you've enjoyed it. I had a lot of fun, and good luck with whatever comes next.